All right. So my name is Kevin Fallis. I'm a principal solutions architect. I work with AWS, and I focus specifically on OpenSearch and ingestion frameworks and all sorts of different tooling out there. Now, first of all, people are going to ask, what is OCSF? Well, OCSF is the Open Cybersecurity Schema Framework, and it's basically a standard that's is meant to help people correlate information and gives you the ability to take all these different types of data sources and bind them into one common schema. Now, it then enables vendors. There's many out there, such as Atlassian, CrowdStrike, Splunk, AWS, all the players that are out there in the observability space that are working with this particular standard. And it really is a domain-specific schema, and it's meant for collaboration. So how does OpenSearch benefit from OCSF? Now, right now, we're in this sort of a new period of trying to define how I transpose OCSF onto an OpenSearch cluster and make it work without having mapping issues and other things along those lines. But we also have an additional challenge of trying to get data transformed, send it to OpenSearch. So there's really the problem on the side of visualizations, mappings, and the other side, which is how do I take my sources and convert those into the OCSF spec? And then in between, we'll use data prep or some other mechanisms to deliver them to the OpenSearch engine. Hopefully all this stuff works together. Right now, it's still kind of needing some work, but we do have a lot of assets we built, and I think as we dig deeper into this, you're going to find it's pretty exciting stuff. So first of all, OCSF with OpenSearch, it gives us a common schema for correlation. And what that means, if we define our mappings correctly, then we're able to look across different data sources, such as an Nginx log, or another activity on EC2 instance, or some network traffic that we want to bring together so we can start doing what are called findings in the security space. And what this then enables us to do is then we can use any sort of data source, we can then transform it, and then get it into a specification that all we really have to do is write a query. Because what's the challenge with OpenSearch? We don't support joins. Crazy, isn't it? Well, then we use schemas now to do that, or we write a custom plugin to do the joins. The next thing is interoperability between tooling. Now, we released something called Direct Query a while back, which gives you the capability to leverage a Spark engine to query S3 or an object store and bring back a result set. And if I can now leverage an object store, I then have ways that I can tier my data and leverage other resources that can give me additional capabilities to help in the security space. Another thing is faster threat detection response. And what this means, if I have this correlation already pre-planned for myself, I don't have to worry about complex queries and joins that I would have to write in other engines to enable me to get that observability I'm trying to find for my findings. It also introduces reduced data normalization complexity. And in these scenarios, by having that common schema, I don't have to worry about certain fields. For example, we have a cloud structure in the OCSF format, and different cloud providers have different attributes, and the spec allows us to then use a similar structure so we won't have to worry about reinventing the wheel across different providers or different implementations. Next thing is enhanced collaboration. Again, you can work with your data scientists. You can work with the people that are creating the findings. You can also work with the people that are hunting and looking for those particular bad actors. Finally, lower operational costs. So in the end, the lower operational costs mean that when I start looking at things like S3 and being able to use an object store to bring my information in and not so much use OpenSearch as a long-term storage location, I now have a way that I can bring costs down. That's really been the big challenge with security solutions, right? We bring all this data in for n number of days or years. We pay all this money for data we rarely use. So object stores are awesome. And this can be part of the talk, too. So, all right. So some of the challenges we have with OCSF, we don't have self-service tooling. So you usually have to wait on someone to build this stuff for you. And so we really want a tool to help assist us in achieving these activities. The second thing is that we can't auto-generate strict index mappings. And if any of you have ever tried to ingest OCSF data in OpenSearch, you have mapping conflicts. And so why not use a tool to do this, right? And then we have to find a sweet spot between Parquet sources and the indexing capabilities that are on OpenSearch. And when we look at visualizations, especially as we head across different versions, we're going to have some problems because sometimes those visualizations may not work because the underlying scheme is going to change. So then we think about tooling to do that for us. Finally, if anybody has done data prepper blueprints, there's a little bit of work involved. And if I can generate that in a future state, it would be great. But this is the challenge we have right now, is that complex data prepper blueprints mean that I take a while to write these pipelines. So what's data prepper? Basically, data prepper is a server-side collector. It enables you to basically transform, mutate, and sorry, it's not slowing down here. Transform, mutate, augment, enrich data, route it, and move it to different locations. So filtering, enriching, transforming, normalizing, aggregating, and then we have the routing functions that can send us to S3 or could send us to Elastic or OpenSearch. And in the end, I can send to both if I wanted to. So it's really a good tool for moving, in this case, pre-transformed data when we start talking about the normalization playground to OpenSearch and give us the capability to route and do some small augmentation. Now, how can data prepper consume OCSF data? Well, for stuff that's already existing out there, we technically can use endpoints such as OTEL or the RPC endpoints that are established in data prepper. We can also use an HTTP endpoint. We can use Kafka. There's an input or a source plugin for data prepper. We can also use Amazon Kinesis. Again, there's another source input. And we can use Amazon S3. So if I'm going to build something, which the tooling that I'm going to talk about with Chris, we can use these endpoints with custom code to deliver our stuff to data prepper. And in the end, guess what? I now have a pipeline, and I can leverage the scale of containers and other commoditized compute on the front side and use data prepper as a delivery engine. So what's missing with data prepper right now? Complex transformations require custom code. We don't have a way that we can inject custom code. Now, we do have a Lambda processor, and we can take these code snippets by using AWS Lambda, but we have wire time. And if you're going to move data really quickly, we're going to have a lot of calls going to ancillary compute that's in band when you're trying to deliver data to OpenSearch. And this is not going to be efficient. Now, we have the wire time latency for those API calls. And in the end, we could use data prepper for most of these mutations, but it doesn't necessarily solve the problem for all of them. And usually when you look at some of the newer things that are coming out, keep your eye on some of the announcements that did happen at the security summits that are out there. But you look at the configurations of the blueprints, you're going to find that there's a lot of extensive configurations out there that are really kind of hard to pile through and read. So if you had an idea in the OCS space, what would you build? Well, here are my thoughts, and this is what I'm trying to enable here, starting with this project. First of all, my dream sheet is accelerate OCSF version adoption for the OpenSearch projects and other projects also, because this tool that we're going to talk about is not just for OpenSearch, and technically it's not just for OCSF. I want to have a low-code, no-code for OCSF content. What I mean by content is things like maybe in the future Sigma rules, but being able to generate these transformations without doing a lot of work. Next thing is prompt-based engineering, supplement with automation, and also assets for each challenge. So I did mention templates or blueprints for data prepper. I mentioned having index templates, which sometimes are complicated to set up. I also mentioned things like visualizations and dashboards. So why build the playground? Many development teams don't have time to understand all the rules. So if you go out and you look at the OCSF spec, and I told you to write some code, you would take a long time to consume this information. You need a tool that can help you make the decisions based on the specification of any version of OCSF. Again, OCSF is not complicated. In the end, it is a very, very expansive schema. And for you to understand it manually, this becomes expensive. Now, multiple categories, classes, versions, and other things of this, OCSF spec can actually sometimes force maybe some deeper rewrites. And if I had a tool to help me do that, I would definitely lean on it. And also multiple transformations can be required. And what I mean by multiple transformations be required, there might be different fields that are not easy just to map from their source, which require a lot of custom code. And you don't necessarily want to write all this. And again, the bad actors out there are using the same tooling that we are. They're thinking about this space, and they're doing it very quick. So we need to think, how quickly can I get ahead of this, and what tools can I enable to help me with this? So we're introducing the OCSF Normalization Playground. My partner in crime, Chris Helma, actually envisioned this and built this product when AWS started stepping in the OCSF space to help us out with OpenSearch in itself. It gives you a solution that helps you develop and rapidly create, test, and create transformations and test these transformations so that you have a means by which you can have a generative AI augmented tool. And so this tool actually uses generative AI and a large language model, Claude, to go ahead and help make these decisions for you. So you have the link right there. Let's go ahead and get into a couple other details here, and I'll kick off this recording. So a typical workflow is going to be, I have the OCSF Normalization Playground. I select my data sources, which we'll see in the demo, which could be a set of Nginx logs. It then uses GenAI to pull that and figure out what your regex or your parsing patterns are going to be. That helps you with the transformations of the fields and gives you recommendations as to what should happen. Once you have that, you're interacting with the model. And then what's going to happen is it's going to give you a complete solution to deploy code that can help you do these transformations. And you don't have to technically write any code, but it does give you the ability to help with writing the code, and you can even put your own custom code in there. Once you deploy the code, you can run it on any implementation of compute that you want to. Containers, EC2, AWS Lambda, even other cloud providers, there's many things out there, right? And so when you look at this and you put it all together as far as what a framework would look like, you have the playground, writes these specific APIs and protocols with your custom code, HTTP, Kafka, OLTP, or the gRPC. It then would be picked up by data prepper across the input or the sources. And then, technically, to save money, we write to an object store. And then we push it into OpenSearch for a short time period so we can do some analysis and maybe findings and use a security analytics plugin. Then you have integrations that can read these data sources. And then, if you want to, you can go back and, for the long-term stuff, leverage direct query to go to Spark to query that same object store. So now I have a profile of cost savings. Now, another hybrid implementation would be take your playground code, write it directly to S3. If I write it directly to S3, I can still leverage the same things. Data prepper has an S3 input plugin, writes to OpenSearch, use integrations to query, I go back to the Spark engine, I go back to the object store. Technically, I don't even have to write anything in OpenSearch if I don't want to. So that's the beauty of this. So let's go ahead and kick off the demo.
So I guess a little bit about myself. My name is Chris Helma, and I'm a principal engineer at Alto Pharmacy. And Alto Pharmacy is a virtual pharmacy. So patients can interact with us to get their prescription. So I guess a little bit about myself. My name is Chris Helma. And
okay. How do I get that out?
I think you'll have to escape out of here and the slideshow.
Okay. Thanks. And let's try this again. Is this better?
And I'm a principal engineer at Alto Pharmacy. And Alto Pharmacy is a virtual pharmacy. So patients can interact with us to get their prescriptions delivered and ask questions. And we primarily focus on fertility and among other things. But we have a really cool tech stack that creates lots of interesting opportunities. And so what I've been working on most recently is updating our architecture to enable us to use more agentic approaches to help customers with their fertility and prescription needs. So that's what I've been working on most recently. But today we're talking about OCSF Normalization Playground, and it's really, really cool. And I think you're really going to enjoy seeing the demo of it. And as Kevin's already talked to you a little bit about sort of the overall problem we're trying to solve here. which is what is a transformation? What does it actually mean to have a transformation? So how I'm thinking about it is there's kind of three components. You need to have a targeting heuristic. So this is relevant because maybe you have a stream of undifferentiated logs, like everything from all your Linux hosts is going into one channel, right? And you have to take this channel and split it apart and turn it into individual streams where you do specific transformations for each data entry type, right? Because you're gonna make these transformations in terms of transformation logic, right? Which is just code or whatever. But like you have to apply the right logic to the right input shape to get the right output. So we have the targeting heuristic, we have the transformation logic, which I've already mentioned, and we have the third piece, which is what is the final shape you're trying to make. And as Kevin mentioned, the OCSF format has lots of different versions and lots of different event classes you can choose from. So one of the little benefits here is if we use an AI assistant approach, what we can do is offload a lot of the knowledge of staying current as standards change, and a lot of the work in trying to interpret and understand all these data entry starting input shapes, right? And offer that to an AI agent that can basically apply the spec in an intelligent way to reduce the time you spend having to dot all the I's and cross the T's. Get you to like an 80%, 90% solution, and then you can make sure everything looks correct, right? And the idea is that we have this tool, you can build up a full library of transformations that once you build it for a particular data entry type and one particular version, you never have to do that one again, and eventually the tool puts itself out of work. And as you have novel use cases come up, obviously you'll have to pop in again and use it again. But once again, the goal is always to put the tool out of work. So hope that all makes sense. So let's take a look at the tool itself. So as Kevin mentioned, this is an open source project, happens to be under my account, but if you just search for OCSF Playground on Google, you find it pretty quickly, or you can use the link or the QR code that he had in the slides. But basically, all the code is here. As you mentioned, it's kind of two components. There's a front end, which is React Cloudscape. There's a back end, which is Django. We use LangChain to shell out to or hit a Claude inference API via Bedrock. There's no reason it has to be Bedrock. It was just convenient to code that way. You can use any AI provider you want with a little bit of effort. LangChain is very flexible, and honestly, everything we've built here is very flexible as well. So even though we're going to be looking at OCSF version 1.1.0 and using Python as a transformation logic, like it's designed from the beginning to be very flexible and easy to sort of swap out those pieces and update them and change them and that sort of stuff. So don't think you have to do things this particular way. You don't have to use Claude. You don't have to use Bedrock or anything like that. Just requires a little bit of effort to swap it out. So I'm here in the repo because I want to grab some example logs. And of course, we have lots of instructions on how to set this up and use it and all that sort of stuff. So right here I have some example logs for SSH connections from Barlog Secure on our RHEL host. So I'm going to copy this and pop over to the OCSF Playground. Ooh. So we've got these two panels. The left-hand side is where we can import some log entries. So in this case, those connection logs. And does the zoom look good on this too?
It does. Maybe pop it up just a little bit more, but then again, okay. For the audience, we'll be on a large screen. For this
better too big than too small.
Yeah.
So, okay. So now we have our log entries imported into the Playground. On the left-hand side, of course, you can, slide things back and forth. But then we have on the right-hand side those three areas I talked about earlier. We have the area for the targeting heuristic. We have an area for the event class we're transforming into, and we have an area for the transformation itself. So let's sort of walk through how we use AI to build out a full transform. So click on one of these example entries over here, which is a failed SSH attempt. So let's get some AI recommendations for targeting heuristic. So basically the purpose of this is to, like, let's say you have lots of different types of logs coming into your data stream. You basically need to like select certain ones out to then apply a transformation to them. And that way you're not, so you basically have one transformation for each type of data entry. So this little section allows you to sort of build a regex, which you can then see here, and then you can test it to see what it selected from this input. So in this particular case, we see that it's able to select all of the failed passwords, but it's skipping the successful SSH attempts and so on. And then we also got a recommendation for what OCS event class we should choose, and there's quite a few of them to choose from. So, and it's sometimes kind of subtle, so it's always interesting to see what the rationale was for the AI. And so we click that button and then see why it shows the authentication event class, which is 3002 and OCSF 1.1.0. So you see it considered SSH activity, account changes and process activity, but it thinks that authentication category is the most specific and accurate, and I happen to agree with that, so that's great. Actually, all makes sense so far, Kevin?
It does. I think, one of the things that I've noticed, and, this is more with the AWS logs, and even more specific with CloudTrail, sometimes those get generated into multiple event classes. Now, I know that we're in the early stages of the tool, but when you look at the potential to have a series of log entries, maybe some of them might split into a different OCSF event class. Is that something your tool is thinking about right now, or right now it's just using the best, or how can I, if I look at, this suite of test events and I decide, well, I think that maybe this is more inclined to be like API activity, which could be like the 6003 series for OCSF. How would I navigate that and work with that?
Yeah. So I guess there's kind of two scenarios there. One is you want it to turn into multiple different, like you want to have the same data entry mapped to two different OCSF event classes, in which case you would basically go through this process twice and make two transformers, right? But if there were either one of them, you would basically just select a different thing here, if that makes sense. So if you really think that it should be, what was it, SSH activity, for example, as opposed to authentication, just do that.
Yeah, cool. Yeah, I think, and you have the selector on the left-hand side, so I could technically just select a bunch of log entries, right? And as long as the pattern matches and the validation passes, then technically I could take the transforms and apply those in my own code, using some conditional statements, right?
Yep, exactly that. And we'll see how the transformation stuff works in a couple seconds.
Cool.
So actually, let's go ahead and click this button. So that's the first two portions of a transformation. We have the targeting heuristic, the event class, which is what you're trying to turn it into, and then you have the section for building out the transformation logic itself. So I'm going to click this button, which is Analyze Entities. Perhaps you need to select an example. Here we go. So Analyze Entities sounds pretty mysterious, but really what it's doing is we're taking the OCSF schema for this authentication event class, and we're giving it to Claude and asking it to work backwards from the spec to figure out what bits of information are in the original log entry we have selected over here that are relevant to fill out and populate this schema. And if there are sections of the schema that doesn't have anything it can pull from, it still will give you a portion of the transformation that you can fill out yourself. So for instance, like if it doesn't see anything there for a particular entry, well, we can actually just take a look at the example. So let's see here. Here's a good example. Okay, so it pulled out things like time, status ID, the message, the username, status details, source IP, ports, all that sort of stuff. But we see that, and so we have raw entity values for these because it found portions of the original log entry that had those. But it also knows that like category ID is required by the OCSF schema, but there was no value in there to really tell you what that was, right? So it creates a placeholder for you to know that you need to fill this out, and even suggests, hey, like this should be 3 probably, right? We'll see in a second that we can actually go further, and it'll create the transformation for that. I just need to click this button right here. So what this button does is, now that we have like an idea of all the paths we need to populate in this final JSON blob that is this OCSF shape in the end, right? Let's create some Python code that first extracts relevant portions from the original entry and then transforms those into the correct final format they need to be to satisfy the OCSF specification for each of those individual line items. Yeah, so usually takes about a minute or so to sort of think through that. Any questions in the meantime, Kevin?
Not right now. I'm patiently waiting for the extract entity mappings to come, but maybe we can talk about why that takes so long, and is that a factor because we're using a model behind the scenes and tokens are being passed and all that good stuff, or?
Yeah. So, yes, it is. It's basically an inference call to Claude. Both of these were inference calls to Claude. Claude is a very powerful model. And one of the things that I'm really interested to see if we can get away with is, can we use a smaller, faster model and do our inference in multiple passes? Like you try once and it doesn't work so well, so you try again. Is that faster? Is that better than basically just passing everything to a big, powerful model as a sledgehammer? Open question right now. But the sledgehammer seems to be pretty reliable, so I haven't really seen a reason to stop using the sledgehammer, if that makes sense.
It does make sense. Thanks for the clarification.
Yeah. So let's take a look back at these. So now we see that, okay, a couple things. First off, we can see everything in the original log entry that we have selected that we're extracting in our new transformation logic. So you have a really easy way to sort of see everything that like is being pulled out and you're doing something with, right? So you can spot coverage really fast. We have a table, we see the paths, we have the raw entries in the original log entry, what we're extracting with our extraction logic, which I'll show you in a couple of seconds, the final transformation, transformed form of that. So what's going to end up in the final JSON, and then the result of our validation pass for that particular log entry. So in the context, or for the example of this, this time, let's see what we got here. So the original entry was, it found this, said, hey, this is an event creation timestamp. This maps to the time path in OCSF, and which is required. So then we see the Python code it created for us to transform this particular element of our final shape. And we have all the imports, which are static. Doesn't have an option to import anything besides these. These are just like pre-canned, and we just sort of tell it, hey, you have these available to you in the code you create. So then we have some extraction logic that basically takes the original entry, which is this, and pulls it out of this original text. And then we have transformation logic, which takes that string and transforms it into the final shape it needs to be in, which in this case we see it started as this and ended up in this more normalized, standardized date time format. And we have a little section here for the validation we're performing. At this point, what it does is it just makes sure that this code is actually runnable, and when you run it, you get something that matches specification. So, okay, so we talked through all of this. Okay, so now we have Python code to extract every one of these line items, and we've done validation for them, and they're all being transformed into these shapes down here. And so now we need to generate our final transformation. And this doesn't go to AI. Oh, actually, I forgot to tell you something really important. You can also, going back to that question of like, how do you sort of iterate on this? You can just like change the code here, right? So like, I mean, who knows, whatever. Actually, let's do, try and pick a better example. Let's do status. Right now we're returning a static value of 2 for failure. Let's just change this to like 77 or something. I don't know, whatever. Doesn't matter. And then you can basically run the test again, and basically sends it to the back end. It will run the validation logic in, and so on, and that sort of feeds into the final transformation. It's like automatically updated for you, if that makes sense. So you can just, if you want to, you can write all the code right here and tweak things and test things and whatever with AI assistants and stuff.
Cool.
So just back. Regenerate that. And so what this final section does is it takes all of these individual line items, and then what it'll do is it will bundle them together. So for each of these individual items, we first run the extraction code, pass that to the transformation code, and that goes to this spot in the final JSON blob. So this is, this is a top level key, but some keys are nested deep. So you may have, well, in the final JSON, we'll have, destination endpoint, and under that host name, and that's where this ends up, for example. So if we scroll down, we can see all the code, which is just the combination of all those line items. And we can see the final transformation. So in the case of destination endpoint, we see we have a JSON blob, ends up with destination endpoint, then host name, and then we see the host name there. And once again, we have a validation section right here, and this is just checking to make sure that every key that is required by the specification is present, and there are no keys that are not in the specification that are present. So we check both ways, if that makes sense.
It does.
That's the playground. A few follow-ups. So as you mentioned, yeah, so there's nothing about this that is specific to AWS or frankly even OpenSearch, right? So this is a general tool to create transformations, and once you have the transformation, you can stick it on any compute you want in any sort of format, whether you're running streaming or batch or anything like that, right? You can be running it on, in a Fargate container as a part of a MSK workflow, or you could be running this as part of Flink, completely open source, or literally anything, right? So it's a very flexible tool, and I think you also mentioned that, yeah, this basically the same approach could be used for other formats. So for instance, updating dashboards across versions, right? You're gonna have a very similar, so like Kibana dashboards, OpenSearch dashboards and stuff like that, right? You're gonna have a very similar workflow, right? So I found this exact framework of the sort of React front end with the Django backend and sort of this architecture useful for a lot of similar conversion scenarios. So maybe you find a scenario where you can just take this code and apply it to a new format even outside the realm of OCSF as well. And in terms of OCSF specifically, a couple areas that I would be really interested to explore next in terms of development would be, as I mentioned earlier, like, can we use a really small model and iterate quickly with that as opposed to give it to a big sledgehammer model like a Claude Sonnet or whatever. And another thing is, of course, adding more transformation languages. That should be pretty easy. That's basically changing the prompt to the AI and the validation logic to just run a different type of language for validation. And of course, OCSF version, which is also really fast and easy, and we have hooks in for that. So yeah.
Cool. So I think another question that will probably come from the audience is, what are your thoughts on hallucinations with the approach that you have right now? And when you, or if you saw that, what was your workaround or thought process into how do you address that? Like, obviously a domain-specific model would be great. That takes a lot of time, right? Leaning on Claude, very, very powerful. I mean,
as we keep on going up the versions, we see a lot better. But remember, Claude's trained against a specific set of data sources,
Yeah, of
and
course.
it is really great at pattern identification. But in some cases, when you think about it, and when you start looking at some of the other tools out there for OpenSearch, like MCP, that the model context protocol stuff, that you can then help use other pieces of code to help make that final decision. I think these are things that I think about. And so,
Yep.
when you look at those hallucinations, what did you find?
Yeah, so I think at the end of the day, like no matter what system you're going to have, you're going to compare it to the OCSF spec, which is what the validation steps are doing, right? It either follows the spec or it doesn't. And in the areas where it's ambiguous, then it's not really, it's ambiguous, right? It could be right, it could be wrong. And it's a human decision, right?
Right.
Like, if there's one thing I've learned about OCSF is like, you can have two people that are technically following the spec but have very different opinions about how something should be done, right? Like what's the correct, like time, we are requesting time, for example, or stuff like that, right? So I think there's always going to be some level of human judgment, but when it comes to spec compliance itself, that is something we can deterministically determine via validation, if that makes sense.
No, it totally makes sense. Yeah, and I like the fact that you not only just generated the transformations, you went right back to the spec and said, okay, let's go ahead and validate it. So you really took a two-phase approach here. It's like, first of all, let's let GenAI do as much as it possibly can do. And then, hey, there is a spec that's out there, and let me interact with that to help me validate. And if it doesn't validate in the way that you think, then obviously I can go in, just as you highlighted earlier, I can edit specific things. Like maybe 1 and 0 or 1 and 2 are not the range. Maybe it is 0 and 77 or something along those lines. So really powerful. But I think, this is awesome stuff. I know that we have a short time with the audience here, and I really appreciate, the time you have today with me. Obviously, I'm remote just like you are, at least for this portion of the recording. I'm getting ready to travel on to OpenSearch.
Time travel.
So, I'll just go ahead and close it. Any final parting thoughts that you want to leave with? Obviously.
So, all right, thanks for bearing with the remote portion of it. As I mentioned, Chris was unable to attend, so we'll kick back into the rest of the presentation. Thanks for your patience. I know would have been better live, but this is my answer to a common challenge, or not so common challenge, which hopefully we are going to meet the rest of the mark here. So, as we look across the board and we start thinking about this particular tool, what's next for the OCSF Playground? Right now we have a very, very small component. This small component is basically something that can help you with transformations, generate all the code used for the transformations, and then that renders that JSON blob. So as a developer working against these, with these tools, I now have a means by which I can have generative AI assisted tooling to help me build the transformations I need for the OCSF spec. Now keep in mind, I only have to do this once per log source. This is a tool to aid in you in building that templatized code. I don't have to keep on running this back through each time unless I'm doing version changes or maybe the spec changes itself. But we still have a lot more work to do, and some of the things I'm pushing in AWS are going to that next step. My ultimate vision is if I can take an OCSF spec and I can generate the transformations, data prepper pipelines in cases where I don't need complex transformations, visualizations and dashboards that couple with that, ones that use the direct query mechanism, using our materialized views with a direct query connectivity via Spark, and also regular indexes, then I have a really powerful tool that as every version comes out, I basically run the transformations, hit a button, deploy, and I have all the content I need. So the laundry list of the things that are next are, first of all, explore iterative inference with smaller models. So we did talk about maybe a custom model. It's for the OCSF standard itself. We are hitting Claude, and as Chris mentioned, we're taking a sledgehammer, but we're using validation with the spec to affirm the observations that the model's given to us. I also want to add support for OCSF versions, or additional OCS versions in transformation languages. Right now, the code base is at OCSF 1.1.0. 1.7 just recently released. I believe that with some of the announcement that AWS has, we're going to 1.5. So there'll be a little bit of work we have to do in the tooling, but I want that to be transparent and automatic. The next thing is having a export load functionality to play better with the larger libraries. Obviously, we see there's some time taken to go out to the model, to get the recommendations and other things along those lines. We want to make that faster. Then again, auto-generate the data prepper pipelines. This is the other sticky part in building a complete end-to-end workflow to get data from the OCSF spec sitting somewhere into OpenSearch itself. And then sort of have that with uncomplicated transformations. The next item is to auto-generate the mapping templates, index templates. For those of you that have even attempted to bring in OCSF data, I probably spent 3 months building all of the mapping templates, component templates, index templates, the visualizations and dashboards. Had I had a tool like this 2.5 years ago when I started down that path, would have totally accelerated things. And having that assistance with generative AI is going to give me that thing that I'm looking for. Finally, visualizations and dashboards. These are always the pain points. If we can build something that can leverage integrations with OpenSearch, then I solve my final part of the equation, which is I have a complete end of observability components. That, coupled with our Sigma rules, then I can start building a broader and more robust security platform using OpenSearch. So, thank you for coming out. Thanks for the hybrid presentation. And, I really appreciate each and every one of you coming out and, watching the talk. And look forward to seeing you all later on tonight and more in the conference. You all rock. Appreciate it. Thank you.